Now that we have our scatter plot, we need to be able to look at it and to make some conclusions from it. So what we really want to think about is whether or not there is some sort of relationship or an association between the two variables. So was there a relationship between the mark and the time spent studying? Well, we found that there was. As the time spent studying increased, the mark also increased. So today we're going to be looking at Pearson's correlation coefficient, and the short notation for that is R. We use a little r for that. Now, Pearson's correlation coefficient is actually looking at how close to a straight line our dots are in the scatter plot. And the closer to a straight line our dots are, we say that it is a perfect positive, and R would be equal to positive 1. If the line or the dots were going the other way and it was an absolute perfect straight line, then R would be equal to negative 1. Just think of gradients. So when it's going down that way, it would be a negative gradient, so negative 1. If it's going up the other way, positive 1. If we have a look at this one here, you can see that there is no real line going through those dots. We can't even see any sort of trend whatsoever. And so therefore R is equal to 0. So Pearson's correlation actually goes between negative 1, which is the smallest value it can be, and positive 1. So it can take any value in between those boundaries, so between negative 1 and positive 1. This table that you're looking at in front of you helps you, once you have worked out, and we're going to be doing that on our calculator, the R value. So once we get an R value, we can come back to this table and have a look and see where it all fits in. Now remember, up the top here, although it's not there, is perfect positive association, and down the bottom is perfect negative association. So R is equal to negative 1. So let's just give an example. If I got an R value of 0.53, you can see that that would be in this area here, and therefore we would be able to say that there was a moderate positive linear association or relationship with the data. If we're only given graphs and not table of values, then it really is just going to be a guesstimate as to what our R value is. So best ballpark figure. But if we're given a table of values, then we should be able to work out, using our calculator, our Pearson's correlation coefficient. In this example, we are given a table of values, so therefore we should be able to work out our Pearson's correlation coefficient exactly. So let's have a look at what this example tells us. The following data shows the per capita income in thousands of dollars and the carbon dioxide emissions in tons of 11 countries. So let's see if we understand what this is saying. So for the first country there, they have an income of $8,900 per capita, and the CO2 emission is 7.5 tonnes. Now, how do you know which is the dependent and which is in the independent? Consider the fact that the more industrialised, wealthy countries are going to have lots more manufacturing and therefore produce a lot more carbon dioxide. So therefore, we would quite naturally say that wealthier countries will produce more CO2. So the CO2 level, therefore, depends on the income of the country. So if this is the case, CO2 depends, it is the response variable, and the country's income is the explanatory variable. It's really important that before we start looking at correlation coefficients or scatter plots, that we always work out our response and explanatory variable. So therefore, what do we know now? Explanatory variable is going to be on the x-axis and the response variable will be on the y-axis, which is important to know when we're entering this data into our calculator. Now, what do we need to do? The question says find the value of Pearson's correlation coefficient. All right, so we're going to do that now on our calculator. And then once we've got that R value, we're going to use the table to be able to work out what the relationship is. So the calculator instructions are there in front of you. We will go through them in class to make sure that you are using your calculator properly. So once we've inputted our data and worked out our R correlation on our calculator, we get R is equal to 0.818. Now, what is that telling us? Well, we need to look back on our table and see what it says. So on our summary table, we can see that 0.818 lies between 0.75 and 0.99, which means that it's strong, positive and linear. So as soon as we have got our R value, we can match it up with our table. So it's a strong, positive linear relationship, and that describes the association between CO2 and income.